We're starting today by graphing y is greater than x plus 3. Now, if I just gave you instead y equals x plus 3, you can graph that pretty easily, right? Go ahead and start by graphing that. And again, make sure you're doing it in pencil for reasons that will become apparent momentarily. All right, so compared with the stuff you're doing in the last unit, this one's not too tricky to graph, right? So we know we have a y-intercept of 3, so I put my first point up at 3. And then my slope here, it's not written in, but what is it? 1. So basically you're going over 1, up 1, all the way along. And do that on both sides, at least enough to be really accurate. Use the straight edge to draw that in. I wish I had a straight edge on this at the moment. To get your line in. Now, this equation, or actually inequality that we are given though, it's not going to be exactly the same as that. This inequality symbol that we have up here, it changes a few things. What does it change when it's y is greater than instead of y is equal? Well, first of all, there's going to be some shading, and so one thing we do for this is we need to shade one side. Now in this case, we want to shade to show that all of the y's are greater, and so we shade in everything above that line. So anytime that you're graphing with an inequality, so greater than or less than, it means you're going to have to do a little bit of shading like this. Now there's one other little detail as well from the way back files of your brain. This one is greater than. It is not greater than or equal to. And it'd help if I was on the right tool there. It's not or equal to like that. If it were equal to, this would be the graph. But when it's just greater than, what other adjustment do we need to make to it? Remember, if it's not equal, that means our line is dotted. Now, if you haven't seen this before, then a little bit of background. Why would we make it dotted? Because we want to show that the graph of all y values that are greater than x plus 3. So that's why we shade this whole area up here. We want to show that that whole thing, every y value up there, every combination works. So for instance, I'm just going to grab a random point here. That point at -4, 6. Again, I just grabbed it randomly. If I plug that into this inequality, 6 is greater than -4 plus 3. 6 is in fact greater than -1. So it's just shading every single point that could possibly meet that. Except the ones that are right on the line would give us values that were equal rather than greater than or less than. By making that line dotted, what we're saying is that those points that are right on the line are not included as part of the graph. Now let's take a look at another example similar. Although, make sure your graph is looking good first. This is what you should have for a final result. And then, here's our second one. Again, you have some pieces. You're going to get most of the way here, but you might not get all the way quite yet. So you start by just graphing the line. So that means we have a y-intercept of -2. Our slope is 0.5, which, if you prefer a fraction, 1/2, same thing. So that's telling us that from that point we go up 1/2, and we just keep going up 1/2 all the way along that. And then we can use our straight edge to draw on the line that goes through it. Now in this case, notice it is actually greater than or equal to. That little line that says that it's or equal to means that our line will actually be solid this time, because all the points that are on the line will still work. And so you draw in a solid line, and then we shade. Which side should we shade on for this graph? Should we shade above, or should we shade below?
Below.
Well, it is a greater than. Greater than, would that suggest to you above or below?
Above.
Greater is more, greater is above. Yes, indeed. So shade that line above it. And then this is what your graph should be looking like. So in the two examples that we've seen here, we've seen a couple different things. First of all, When we graph an inequality, that is something that's got the greater than, less than kind of thing in it instead of an equal sign. If it is just greater, same thing if it's just less, that means we do a dotted line. If it's greater than or equal to or less than or equal to, that means you're going to be doing a solid line when you graph it. And then greater tells you shade above, less will tell you to shade below. We're going to use that same general rule on this one. All right, and so in making this graph, notice it's in point slope form. So you start by going to the point. Now the point identified here is at -2, +7. So put your first point there at -2, 7. And then my slope is whatever is multiplied out front of those parentheses. In this case, it's that negative. So your slope here is -1. So from that starting point, down 1 over 1, down 1 over 1, down 1 over 1, all the way along. All right, so I plotted my points. I saw where my line was for the same as if it were just equals. Now in this case, seeing that this is a greater than symbol, should my line be solid or dotted? Dotted. Dotted, absolutely, because we want to say that the individual points that are actually on that line, they're not included. They're not included in the shaded portion. They're not included as part of the solutions. So I make it dotted. And now I need to shade it. On which side should I shade this graph? Above it or below it? Above it, yep. Because it's greater than, and greater means above. So you shade above it. So then I think you got all the tools for being able to do this one now. You've given lots of practice. Go ahead and graph this one, start to finish on your paper there. Again, remembering to write the inequality above the graphing grid before you start. All right, so to graph this one, we have a y-intercept of 1, so I start up 1. And then my slope is 2, so from that starting point, up 2 over 1, up 2 over 1, it is an or equal to here, so that means that it is going to be a solid line. And then we shade below because it's less. We're next going to see how we can graph these inequalities from standard form as well. So again, please write this inequality above your next graphing grid and start going through the process of going ahead and graphing it. Just as if it were or equal to, we just have a couple extra rules about solid or dotted and some shading stuff. And so in order to make this graph, we do have to do a bit of work. We have to figure out the x-intercept and the y-intercept, which means the point that's something 0 and the point that's 0 something. And so for this first one, I'm plugging 0 into y, which means that I'm left with 2x equals 12, and if 2x equals 12, then x is 6. So that gives me the point 6, 0 to plot and graph. Now we go to the other one, and this other one here, the x is 0, so I plug 0 in for x, which makes that term disappear, so I have 3y equals 12, and if 3y equals 12, then y must equal 4. And so then I go to the point 0, 4, and I plot that one. Then with your straight edge, with your ruler, go ahead and draw the line that goes through those 2 points, and when you draw it in, should it be solid or dotted? Dotted. Should be dotted, yes. Because this is a less than symbol up here, not a less than or equal to. If that little line were underneath it, then it would be solid. Now I have one more step here, and that is shading. Now one thing to be aware of, in the previous problems where we did the shading, the reason why greater meant shade above and less than meant shade below was because they're all actually basically set equal to y. The y was alone on the left-hand side. In this case, the y is not alone on the left-hand side. And so there's some little detaily rules. I'm just letting you know ahead of time that there are some little details that we can end up worrying about later. And so because there are some things like that that can throw it off, I'm going to show you one more way that we can know which side to shade on. Although your intuition in this case is going to be correct. We are going to end up shading below. But I want to show you how else we can know that. I'm going to pick some point that is not on that line that I graphed. It can be any point up here. It can be any point down here. It doesn't matter. So let's pick one randomly. What's a nice, easy point to work with? So we got the 0, 0 is an easy point. Okay, so I'm going to take this point here at 0, 0, and I'm going to plug that in my equations, or in my inequality, and see what it gives us. So I'm going to go 2 times 0, because my x value there is 0, plus 3 times 0 is less than 12. Okay, well 2 plus 0 is 0, 3 times 0 is 0, so I end up with the statement 0 is less than 12. Is that statement true? Yes, it is. That means that this point that I just tested here needs to be shaded. And if that point is shaded, then every point on that side of the will also be shaded. Which not only lets you know why it's less than, but also reminds you, what does that shading really mean? That shading represents every single possible XY combination that works. Every possible XY combination that will actually be less than 12. Now with that in mind, we're going to do one last one together. Go ahead and take it up through drawing the line, but wait to shade, please. And so in order to do this one, we find those x and y intercepts. So that is something comma 0 and 0 comma something. And so if I plug 0 in for y for that first one, 10x equals 20, so x is 2. On the second one, x is 0 in that case, and so I have negative 4y equals 20. And if negative 4y equals 20, then the y is negative 5. All right, so then we have 2, 0, 0, negative 5, and then draw the line through those 2 points. And this is where you would have stopped and waited. Because I had you just draw the line here, because the shading is going to be a little bit more interesting. So once again, I want to pick a point that is not on the line, anywhere not on the line. Now the last time we used 0, 0. In fact, 0, 0 is the one that I tend to go to most, just because it's really easy to work with. But I want to prove to you that this works with other numbers as well. So I'm not using these numbers for any particular reason, other than just to show it doesn't always have to be the same. I'm going to pick the point here. I like this point. I'm going to pick the point 1, 2. And that's the one I'm going to test. Because the whole idea here is that if that works, every point on that side will also work. And if it doesn't, then that tells me to shade on the other side instead. So I'm going to take that point and plug it in. So I go 10 times x, which there is 1, minus 4 times y, which in this case is 2, and it's greater than or equal to 20. I want to see if that is in fact the case. So that's going to be 10 minus 8 is greater than or equal to 20, which is 2 greater than or equal to 20. All right, so is that statement true? Is 2 greater than or equal to 20? No, it's not. So that does not work, which means that this point here that I was testing doesn't work, which means that side should not be shaded, because that side represents everything that wouldn't work. So I have to, in this case, below. Now notice here, it was a greater than. It's only in standard form that we're really going to have to mess with that and test points so much, because on the other ones, when it was just a y and then our equation, whatever this was over here, then greater will be above and less will be below.